Okay, so now we will discuss about the code demonstration for our project character recognition using maximum correlation from optical scanned images. So before we go to the code demonstration in MATLAB, let us refresh our idea about binarization. Binarization is pretty important step because this step uh, is a marker where we convert the image which is basically in RGB or CMYK or in grayscale to complete flat black and white image. So how do we do that? We have a specific threshold value below the pixel intensities which are lesser than the threshold values should be converted to black, and the intensities which are greater than the threshold value should be converted to white, and this threshold value should be normalized in between 0 to 1 because because it is a coefficient, or it is a value which has to be normalized all the time. And we do this with the help of OTSO method, and this thresholding is automatic. It depends on the input image. If we use different images, the threshold is varying based on the pixel clusters which are more on brighter side or on the darker side. So for example, if we have L gray values, and we segregate N1 as the number of pixels which are having 1 as the gray value, 2 as gray value is N2, 3 as gray value is N3, and they all should add up to capital N, which is the number of pixels in that image. So this is pretty straightforward. So what we do is we try to form clusters or classes of pixels which have intensities lesser than the T, and which are pixel intensities greater than T to the cap L. So what we do is we try to find the mean and the class variance of those cluster classes, those cluster pixels. So basically this is the mean of both the clusters, and this is the weight. Um, this term is very important because this is the in between class variance. What it means is we have a cluster, or we have a class of pixels which belongs to black or darker, and class of pixel which belongs to light, which is white. So this is variance. This variance is basically how apart are the means of those individual classes. If the means are far apart, so it is easier to find a mid value threshold. If if the if the variance is narrow, or the pixel clusters are very close to each other, we have to devise a method so that it is far apart, and then we can have a threshold value in between. So sigma b square, this derivation gives you an insight about how do we evaluate the in between class variance. So we have to maximize this in between class variance. So that is done by OTSO method, and we call the OTSO method by using the function gray thresh. So coming back to the code, we have 1, 2, 3, 4, 5 codes. The main code, the first initial is training the algorithm with all the numbers and the letters. So this is basically 1, 2, 3, 4, all the numbers, all the letters in cap, and all the letters in small. So you can see that all the letters are stored in the form of bitmatch images, in the form of different images, and the size is 24 cross 42 all the time. These are letters, these are numbers, and these are the letters. So each letter or each number has got the same name as the file name, and this file name is loaded onto the same name itself on MATLAB, and we create letter vector, we create number vector, and we create lowercase letter vector also. This character is the entire set of metrics, or it's a complete exhaustive matrix which includes all the letters, all the numbers, and the lowercase as well. So basically character, which is later converted to a template.mat file, has got all the letters in uppercase, all the numbers, and all the lowercase letters. So each letter or each number in the library will correspond to the specific letters or the numbers in the library, and when we try to correlate each letters which is cut out from the main image, each letter is correlated with this character or the template, mat file, and then that correlation coefficient stands or it points to the specific letter which has maximum correlation, and that is the correct in most of the times. So we run this main recognition algorithm. This is where we scan the image. We have used a test im1.jpg. You can see the test im1.jpg is this one. It is a handwritten text written by me. So this scans the image. Now we convert it to a grayscale image, and here you can see that it is a histogram. We will see that histogram is an important word. It shows the number of pixels it shows the pixel index with the intensities on the graph. This T is the threshold value, the O2 threshold, which is called with the help of gray thresh, and the scanned image is passed. This when the threshold is occurring, this entire white pixels are converted to black, and all the entire black pixels are converted to white. So this is just a complementary operation. So that segmentation is very easy if the letters are over a black environment. Also, we have the user to input a specific number of pixels. So that number of pixels, all the components which are lesser to that pixels will be removed. I mean, if there are connected letters, or there is a lump of pixels which are connected, which are of no use, those has to be removed. So this is the morphological opening that we talked about just now. And again, after all this pre-processing, we generate a histogram. So this histogram should definitely be a solid line on the black and a solid line on the white. So we go to our main loop. Here we load our template, and here is the output text file that we are supposed to have all the generated data. So when we start off this loop, the image is passed, and it is passed on to segment line. So what segment line does is it clips the lines from the entire paragraph, and the function clip definition declaration is up high, and definition is lower or down there. So it tries to take out each line and pass each line. Say FL is the first line, and the remaining line is this vector. So each line is returned back to the main function, and that FL is again passed on to segment letter, so that each line, now each word has to be, or each letter has to be extracted from that line. So you see that segment letter is the function segment letter is called. So here segment letter, it's pretty much the same thing. It is doing what it was doing in segment line. It is just taking out each word and then clipping out each letter out of each line, and then storing it in a vector, and then passing it back. So now when it passes it back, it is resized, as I said, in the 42 cross 24 cross 42 pixels, so that it has to match with the ones in the template. So now this recog-algo function, it calls the core2, which is very important. This core2 calculates the correlation coefficient, and say correlation coefficient, if the correlation coefficient is maximum with the first element of the template mat file, so that is to be definitely cap A, because in the template file, see, this is the template file vector. The first letter index is 1, A, cap A. The cap B has the index 2, and likewise. So if it is 2, it is cap B. If it is 3, it cap C. So this is how it returns which value it is for, and then exactly that letter is returned, and we form a vector with that letters. Also, you can see that at each spaces there is a separate loop which counts the line space in between words. Also, it counts the line break, because it is important to have equal amount of it is important to have proper line break and proper in between word separation, that there is actual word separation and line break in the scanned image, and ultimately the output is outputted in the text file. So if we run this, you can see the histogram. This is the histogram of the original grayscale image. You see all the pixel intensities are on the lighter side because the image is white is more dominant in this image. So say we select pixel number of pixels, say 20. So all the objects with lesser than 20 pixels, connected objects, will be removed. So you can see that the solid line, as we have discussed below, solid line on the image histogram after binarization. So, and this is the main binary image, purely black and white, and ultimately we have the text file. We have a little bit of problem. The S has been detected as G and the D has been detected as O or 0, but this is not the fault of algorithm, but it is sometimes the type of scanning that we have done when it is up to loading the templates. If we have a proper template, we have this problem solved. Now you can see the elapsed time. It is taking a lot of time, which is understandable because it is a handwritten text, and it takes a lot of amount of time when it deals with a handwritten text. If we open up this is the threshold. Threshold is something around 0.567. This is very tough to explain on theory, but we have the calculation gone in background with the OTSO method, and this is what we get when it is normalized. Now we close everything else and we try to load a different image. So IM2 is basically this image. It is a pretty straightforward standard writing and of 2 colors, but it is not a handwritten, so we expect to see lesser execution time. So let's see what we have. If we run this, we have say 20. We have a lesser execution time. Yes, and we see a lot of anomalies like I is confused with L, but the and there is a space missing in between. But the overall sense is pretty clear because any recognition algorithm is not 100% accurate. Even though even a neural network algorithm is implemented, it is not perfectly correct. So we have a good amount of accuracy in our project. Now let us see what actually is going around at the background. If we try to uncomment some of the pads that I have written in the code, you can see that each letter or each line is extracted out. See FL, as we have said that FL is first line. The loop goes on for the first time, so it takes up first line. If the loop goes on the second time, it goes the second line. So if we remove this figure, this uncomment it out and let us run it, you can see the 20. So you can see each and every line is extracted out, and which is correct. Each line has to be extracted out in our algorithm. Likewise, let us stop it. Now let's try to see how each letter is extracted out from each word. So we can either remove this command or we can remove a comment from here, but for the sake of keeping it easy, we remove a comment from here. Run it. See, each letter is extracted out, and which is what we expected. So thank you for considering to see my project. We had a lot of we have a lot of trials and error, and it took a long time to load the images onto the library and trying to come up with a good algorithm by correlating, and we see a pretty much good amount of accuracy. But this accuracy goes down if we try to use a different sort of images, and if we try to remove more pixels, which is a good example. But keeping it 5, keeping it low, is a good approximation. Also, you can see the t-value is 0.625, which is different than the previous case. Earlier it was pretty much something around 0.5 or something. Now it is 0.62. So thank you very much.